This tutorial is based on a problem presented by one of our viewers in the comment section. They have an online production plant analyzer, which creates a flat file every 5 seconds. The problem is, they want this data to be automatically loaded into SQL. Although it is good for practice and learning, but this is not the recommended method. It is better to have the analyzer store data directly into SQL Database. But we will still attempt this, for the sake of learning, or assuming we don't have any other choice. We will use HTML and JavaScript to simulate the online analyzer which generates flat files every 5 seconds. Then we will use SQL query to import those files into a table. Finally, we will display the data into a Power BI dashboard. In your computer, create an HTML file. Open this file in any text editor of your choice. We will use Visual Studio Code Editor. We will use this HTML document to simulate an online analyzer. This will generate a flat file every 5 seconds and place it in the Downloads folder in our computer. Create an HTML element. Add a head element to your HTML document. Add a body element to your HTML document. Add a title element within the head section. This title will appear on your tab in HTML browser. Add a heading for your title. This will display title at the head of the HTML document. Your document currently looks like this. Add a picture or graphics relevant to your application. We will add this animated graphics file, which we downloaded from the internet. Let's see how it looks. Remember, images downloaded from the internet are copyright protected. Here it is only added for demonstration. Add a paragraph tag to show the status of your application. Add another paragraph element to display current file name. Add a JavaScript tag to add JavaScript code to your application. Add a variable named timer. Add a function to start the production plant analyzer simulation. Add this function's name to the start of the script to start this function automatically when the page is loaded. Add a starting message to the status paragraph element. This message will appear as soon as the page is loaded and the start function is called. Let's check the code. Here is our message. Create a timer loop, which will keep repeating after every 5 seconds. Define time here. Create a variable, and store current date in it. Create variables for year, month, day, hour, minute, and second. Using the date variable declared earlier, store each value in their respective variable. In JavaScript, month and day are zero-based, therefore, add 1 to each of them. Create another variable, and store all these variables in it after combining them, separated by a dash. This variable will be used as file name. The flat file that will be downloaded every 5 seconds. Declare a variable for temperature, and store a random number, greater than 80, and less than 100. Declare another variable for power, between 8 and 10. Add another random number variable, slightly less than the power. Add a variable output, by multiplying power with variable m. Calculate and store loss, using power and the output. Create and store data in comma-separated form, including file name, temperature, power, output, and loss. Display status in the status element. A simple working message is enough. Display the name of file application is currently working on, in the file name element. Create a new blob in the JavaScript. A blob is a raw data file, in text or binary form. Add the data to the blob object, and define plain text as data type. Create a URL, to download the blob object as a text file. Create an anchor element, and store it in a variable. This element will be used to create a hyperlink. Create a hyperlink, using the anchor variable. Create a download link, with the file name. Click the download link, to initiate the download process. Release the browser resources, by revoking the URL object. Now, open the HTML file in browser, to see if it works. It seems that the application is working properly. As you can see in the top right corner, the files are downloading. Let's go to the Downloads folder, and see the files. Sometimes, the browser needs permission to download files. If it does, allow the browser to download the files. Permission will be required once only. Now, a flat file will be downloaded after each 5 seconds, as you can see here. We can now go to the SQL Server, and using a query, load these files into the SQL Server database. In your SQL Server, create a new database with appropriate name. Expand the database, and the Tables node. Right-click on the tables, to create a new table. Add a column, to store the name of the file. Choose appropriate data type. Add a column for temperature, with data type float. Add another column for power, with same data type. Add a column to store output percentage. Finally, add a column to store production losses in the plant. Save the table with an appropriate name. Refresh the Tables node, to confirm that the table has been created. Create a new SQL query, and save it with an appropriate name. Create a loop that never ends. You can use a condition that is always true, such as 1 is less than 2. Add the begin and end block. This is where you will add more code. Add a delay of 1 second. Although the production plant analyzer updates the flat file every 5 seconds, we cannot use a delay of 5 seconds here. If we add a delay of 5 seconds, the SQL will not likely read the file. For example, if the flat files are saved in 1st, 5th, and 10th second, SQL may be reading them in 3rd, 8th, and 13th second. And since the name of files are based on time, therefore they will never be read. We will therefore go through all 5 seconds, not missing any digit. Now, create a variable to store file name, which derives from date and time. Use the concatenate function to combine strings. Use the datepart function, to get year, month, day, hour, minute, and second, from the date. GetDate function will give you current date and time. Use the dash as separator. Copy the same function, including the separator, 5 times for month, day, hour, minute, and second. Change the year to month, day, hour, minute, and second. This will give you file name, based on date and time. Before assigning a value to a variable, you must declare the variable first. Our file name is a string with maximum 20 characters. Declare another variable, to store file name, with its full address, and extension. Choose a larger number, as address can be long. Now, assign the full name of file, to this variable. Use the concatenate function to combine your download folder address, the file name, and its extension. Next, add a try-catch block to your code. 4 out of 5 files that you will attempt to access will not exist. That will cause an error. Try-catch block will make sure your code does not stop. We will use dynamic SQL statement to read the file. Declare a variable, to store our dynamic SQL code, with maximum length. Set the value of SQL variable. Use the bulk insert command, to insert data from text file, into the data table. Enter the full address of the file to read data from. Add other parameters. Enter the symbol used as separator. In our case, it is a comma. Enter the symbol which is used as row separator. Tell the SQL where to start. If your flat files have headings, you may want to start at row 2. In our case, our first row is data. Add the code to execute the dynamic SQL command. Another important thing is, to keep this code few seconds behind the current time. This will a lag of 5 seconds, making sure that the flat file has been created. It's time to test the system. First, check if there is any data in the SQL table. Run the application by opening the HTML file in the web browser. Now, execute the SQL query. Allow the browser to download files. Confirm if the files are being downloaded. Using the select command, we can view the data in the table for confirmation. As you can see, the data is being entered correctly, which means the system is working. However, this method is highly discouraged. Add a title to your dashboard, using the text box visual. Add a measure, with 0 value. Add another one, with the value of 12. And another, with the value of 120. Add a gauge visual. Add the power field to the value area of the gauge visual. Add the M0 and the M12 to the minimum and maximum values. Create a copy of this gauge visual and place it next to it. Replace the M12 with M120 as maximum value, and the power field with the temperature field. Change the values of both gauge visuals to average. Add a donut chart to your dashboard. Add the output and the loss fields to the values area of the donut chart. Make a copy of the donut chart and change it to a scatter chart. Change the X and Y axis fields to don't summarize. Finally, turn on the page refresh, setting the refresh time to 5 seconds. Delete all the data from SQL table. The dashboard should display blank data in around 5 seconds. Execute the query. Open the HTML file in the web browser. Allow the files to be downloaded. Now, you can see that the dashboard is updating after 5 seconds, which means that the system is working. The data is being downloaded into flat files after 5 seconds, which is being entered into the SQL Server database. And then, it is displayed in the Power BI dashboard. Thanks for watching. We hope you liked our tutorial. Don't forget to like and subscribe for more tutorials and updates.